Imagine for a second that you're sailing across a huge open ocean. You can feel the wind in the sails pushing you towards some distant shore. Okay, now let's swap that ocean for the pure void of space and swap the wind for nothing but sunlight. It really does sound like something straight out of science fiction, right? But this is the incredible reality of solar sailing, a technology that could totally redefine our journey to the stars. And you know what's crazy? This dream is not new at all. We're talking 4 centuries ago. Way before we even understood the physics of light, the astronomer Johannes Kepler saw comet tails always pointing away from the sun, and he imagined, what if we could harness those same heavenly breezes to explore the cosmos? That is the big question, isn't it? I mean, there's no air in space to push against. So how can light, which we're always told has no mass, possibly push anything? Well, the answer is hiding in a really subtle but incredibly powerful principle of physics. To really get our heads around solar sailing, we first have to understand how something as, ethereal as light can actually give a physical spacecraft a nudge. The secret sauce here is something called radiation pressure. So think of it like this. While these little particles of light, called photons, don't have any mass, they do have momentum. It's kind of like a stream of water hitting a paddle wheel. When just countless photons slam into a surface, they transfer that momentum. The physics is actually pretty cool. Imagine a photon is like a tiny little ball. If you throw that ball at a wall and it just sticks there, it gives the wall a little push, right? But if it bounces off a mirror, like our sail, it's like the ball recoiling, and that action transfers double its momentum, giving the sail an even bigger kick. Okay, but just how big is that push really? Well, for a truly colossal sail, we're talking 800 by 800 meters. The total force you get from sunlight here at Earth's distance is only about 5 newtons. To put that in perspective, that's about the weight of a single piece of paper sitting in your hand. So how in the world could that possibly move a spacecraft? Here is the secret weapon. It's not about how strong the push is, it's about its persistence. Think about it. A rocket burns all of its fuel in one powerful, very short burst. A solar sail, though, it's being pushed constantly, every second of every minute of every day. This gentle, absolutely relentless acceleration just adds up and up over months and years, letting it reach these enormous speeds, all without carrying a single drop of fuel. So the theory checks out, but how do you actually go about building one of these massive gossamer giants? Well, it turns out this is one of the most extreme engineering challenges we've ever tried to tackle. And hey, this isn't just on paper. Back in 2010, Japan's IKAROS probe proved that this whole concept was totally viable. It became the first craft to successfully sail in interplanetary space. It actually flew by Venus, powered only by the light from our sun. Amazing. For these sails to work, they have to be unbelievably huge, yet impossibly light. We're talking about a mirrored surface made from something like aluminized Kapton film, stretched out over an area the size of a football field, but it's only 2 micrometers thick. That is way, way thinner than a single human hair. The whole goal is pretty simple. Make the area as big as possible to catch photons, while making the mass that needs to be pushed as small as possible. And there isn't just one way to design them. The most common one you'll see is the square cell, which is held tight by these rigid booms. But there are other wild concepts out there, like the heliogyro. It uses these long spinning blades that unfurl kind of like a helicopter, and it uses centrifugal force to keep them stiff without needing any heavy mass. Okay, so we can build them, but what could these incredible machines actually let us do? Well, the potential uses are just as revolutionary as the tech itself. Just take a look at these numbers for a mission to Mars. An 800-meter sail, it could get a 2-ton payload there in about 400 days. Not bad. But if you scale that up to a 2,000-meter sail, you could be delivering 40 tons of cargo. This completely transforms solar sails from some cool novelty into a potential interplanetary shuttle service, constantly ferrying supplies to a future Mars colony without ever needing to refuel. But it gets even more exotic. Get this. Imagine a spacecraft that doesn't need to orbit at all. By perfectly balancing the sun's gravitational pull with the push from its light, a solar sail could basically hover in a fixed spot in space. This theoretical craft is called a statotite, a truly static satellite. It just stays put. And a satellite could do some unbelievable things. Imagine putting one over one of the poles of Mars, and it just sits there, acting like a giant stationary mirror, focusing sunlight right onto the polar ice caps. This could be a tool for terraforming, slowly warming up the planet's atmosphere to make it more hospitable. I mean, what an absolutely monumental idea.
So, solar sails are incredible for zipping around our own solar system. But if we want to reach for the stars, well, we're going to need a much bigger push.
The problem with sunlight is that it gets weaker and weaker the farther you go. For true interstellar travel, the sun's push just isn't going to cut it. So, what's the solution? We bring our own sun. This is the idea behind a beamed sail, which would be pushed by an immensely powerful array of lasers right here from Earth. And the speeds we're talking about here are just staggering. A beamed laser sail could theoretically push a tiny probe toward our nearest star, Alpha Centauri, at 11% of the speed of light. A journey that would take our fastest spacecraft today tens of thousands of years could be cut down to just a few decades. So you go from a 400-year-old dream to a real technology that could completely reshape exploration. Solar sails really do represent a huge leap in how we even think about space travel. They're slow, they're patient, and they're pretty elegant. The question isn't really if they work anymore, but just how far are they going to take us?